Hello, and welcome to our last video on simplifying radical expressions, this time dividing. Dividing is one of those things that always tends to scare people because they think of fractions. But you know what? This won't be so bad. Okay, some of these techniques you're going to look at and say, wow, that's really easy. And other ones you might take a moment and say, okay, I see where he's going. But let's see how we can handle this. So, what we have to remember now is, whenever we have a perfect square inside of a radical, we can take the square root of it. If we don't, we want to look for perfect square factors of them. Okay? So now, when we look at this, we see the square root of 9 over the square root of 4. Well, we know the square root of 9 is 3, and the square root of 4 is 2. So, the square root of 9 divided by the square root of 4 simply simplifies as 3 over 2. And that's it. Oh, hopefully they're all this easy, but you know what? They're not. Let's keep moving. We have the square root of 16 over the square root of 4. Both of these, again, are perfect squares. The square root of 16 is 4. The square root of 4 is 2. It's 4 over 2. But wait, we're not done. Why? We can reduce. 4 divided by 2 is simply 2. Always ask yourself before you're done, is there anything else I can do? Let's look on to the next one. Number 3. The square root of 5 over the square root of 20. Neither of these are perfect squares. But you know what? Can we reduce 5 into 20? We can. 5 goes into 5 once. 5 goes into 20 4. And we're left with the square root of 1 divided by the square root of 4. Now look at that. They're both perfect squares. The square root of 1 is 1, and the square root of 4 is 2. So our answer to this is 1/2. Let's take a look at another one. How about the square root of 15 over the square root of 9? Oh, 3 divides into both those. But wait. Do you notice that we have a perfect square down here? Let's take care of that first. The square root of 15 over the square root of 9 is 3. We might ask ourselves, can we simplify the square root of 15 like we've done in the past? Well, are there any factors of 15 that are perfect square? There are not. It's only 3 times 5. We can't simplify that. So, you might ask, well, can I divide 3 into 15? You really want to, but you notice how this 15 is inside of a square root? Just like when we did multiplication, and we multiplied outside with outside, and inside with inside, the 3 is on the outside of a square root, and the 15 is on the inside, so we cannot divide those. This is as far as we can go. Let's move on to the next one. Number 5. And I'm going to switch up the color here. I feel a little green today. So, neither of these are perfect squares. So let's see if we can do any reducing. Does 2 go into 32? It does. 2 goes into 2 once. 2 goes into 32, 16. So you're left with the square root of 1 over the square root of 16. The square root of 1 is 1, and the square root of 16 is 4. So our final answer is 1/4. These haven't been so bad, have they? Now, let's move on. Well, we have the square root of 3 over the square root of 2. Well, neither of those are perfect squares, but hey, we cannot take the square root of either one of those, and we can't reduce them. What do? Well, here's the deal. We have a rule that says we cannot leave a square root in the denominator. This square root of 2 can't be left here. So how do I get rid of it if I can't take the square root of it? Well, we do a little bit of multiplication. It would be great if what's on the, It would be great if what's on the inside of this was a perfect square. Well, what do I have to multiply 2 by to get a perfect square? I have to multiply 2 by 2. I have to multiply 2 by 2. So I'm going to multiply. Why does this keep happening? I'm going to multiply this square root of 2 times this square root of 2. Because in order to multiply a 2 on the inside, I need another 2 on the inside. And then, because I multiply the denominator by the square root of 2, I multiply the numerator by the square root of 2. What this right here really is, this thing is really something over itself is 1. And if anytime you multiply anything by 1, you don't change its value. So, I'm not going to change the value of the square root of 3 over the square root of 2. I'm just going to change what it looks like. So now, when I multiply this, I get the square root of 6 over the square root of 4. I can't simplify the square root of 6 because that's just 3 times 2. But I can take the square root of 4, which is just 2. Again, the 6 is on the inside and 2 is on the outside, so we can't reduce those. So my final answer is the square root of 6 over 2. This process right here is called rationalizing the denominator. Because we're turning the denominator from an irrational number, square root of 2, into a rational number, 2. Let's see what other opportunities we have to try this out. Now, we have the square root of 4. Oh, we can simplify that. Let's change that to 2. Over, we can't take the square root of 3. But we can't leave that square root in the denominator. So what we're going to do is multiply by what will make this a perfect square. So we're going to multiply it by the square root of 3 down here. And if we do it in the denominator, we must do it in the numerator. So, the square root of 3 times the square root of 3 is the square root of 9. And 2 times the square root of 3, 2's on the outside, 3's on the inside. So we can't multiply the 2 and the 3 together, so it's just 2 square roots of 3. We get 2 square roots of 3 on the top, and the square root of 9 is just 3. Again, you can't reduce these because one's on the inside and one's on the outside of the square root, and that's our answer. Let's skip over and try some more down here. Uh-oh, do we have numbers on the outside? Does that change anything? No, it doesn't. So what we can do is we can do 5 times. What's the square root of 4? It's 2. Over the square root of 3. That becomes 10 over the square root of 3. We still have that square root of 3 in the denominator, so we're going to rationalize it by multiplying by the square root of 3 over the square root of 3. 10 times the square root of 3 is 10 square roots of 3. And the square root of 3 times the square root of 3 is square root of 9. 10 square roots of 3 over, what's the square root of 9? It is 3, which is our final answer. Let's try one more of these. Let's look at this. Oh, do you notice something here? We have a 4 outside of a square root and a 2 outside of the square root. We could actually reduce this first. 2 goes into 2 once, and 2 goes into 4 twice. So you reduce to get 2 over square root of 2. But we still have that square root of 2 in the denominator. So in this case, I'm going to multiply by the square root of 2 over the square root of 2. 2 times square root of 2 is 2 square roots of 2. And the square root of 2 times the square root of 2 is square root of 4. We can then simplify the denominator and say the square root of 4 is 2. And look, we have a 2 on the outside down here and a 2 on the outside up here. These can cross out, and you're left with just the square root of 2. What that means is this whole expression that we started with simplifies all the way down to the square root of 2. Let's try some others. And if you see these coming up, they're starting to get a little bit more involved. You notice we have negative 5 plus the square root of 3 on top. You have 2 terms. We can't add those together like you learned back when we did adding, subtracting radicals. This is a square root of 3. This is just a negative 5. But we can take care of having this square root of 3 in the denominator. What we're going to do is multiply the denominator by the square root of 3. And if we do that down there, we're going to multiply the top by the square root of 3. Now the bottom's nice and easy. The square root of 3 times the square root of 3 is just square root of 9. The top is a little bit more work. Do you notice we have 1 plus 2 terms? We have to treat this like a binomial, in which case we have to distribute. Like you learned last week, we're going to multiply the square root of 3 times negative 5, which would give us negative 5 square roots of 3. Outside with outside, and remember there's a 1 in front. Inside, well, there's no inside here, times inside here. That's why it's negative 5 square roots of 3. Plus, what's the square root of 3 times square root of 3? Square root of 9. So we have negative 5 square roots of 3 plus the square root of 9 is 3. All over the square root of 9 is 3. Now, I see a lot of 3's there. It looks like we can cancel out. We can't. You can't cross out this 3 with this 3 because this is on the inside of the square root and that's on the outside. We can't even cross out this 3's here. And it's a very difficult thing to think about, but this 3 has to divide into both the negative 5 square root of 3 and the 3 at the same time. Because it can't divide in over here, we cannot divide it out over here. So this is as far as we can actually simplify it to be. Let's try another one. Here I see 4 plus the square root of 2 over the square root of 5. I got to get rid of that square root in the denominator, so I'm going to multiply the top by the square root of 5 and the bottom by the square root of 5. Okay? Square root of 5 times square root of 5 is square root of 25 in the denominator. And the top, again, we have a binomial here. So we have to distribute through. 4 times the square root of 5 is 4 square roots of 5. And the square root of 5 times square root of 2 is plus the square root of 10. The square root of 25 in the denominator just becomes 5. Now, can I simplify the square root of 5? No. Can I simplify the square root of 10? I can't, because I can only break it apart into 2 and times 5, and neither one of those are perfect squares. So it just becomes plus the square root of 10. I can't add these two terms either, because that's a square root of 5 term and that's a square root of 10 term. Those are different inside radicands, so you can't add them together. Okay? So, this is as far as we can actually go. You can't divide the 5 into 5 because that's on the inside, that's on the outside. Again, 5 divides in here, but it's on the inside here, it's on the outside there. That's as far as we can go. Let's try one more of these type. Okay? Here, you probably see the process here. We got to get rid of that square root in the bottom. So we're going to multiply the bottom by the square root of 2 and the top by the square root of 2. The bottom times the bottom is the square root of 4. The top times the top, again, binomial. We distribute the square root of 2 through. So what's the square root of 3 times the square root of 2? The square root of 6. Minus, what's the square root of 2 times the square root of 2? Square roots of 4. We can't break this apart because it's only 3 times 2 and neither of those are perfect squares. So it stays the square root of 6. Minus, what's the square root of 4? It's 2. Over, the square root of 4 again is 2. And we're left with just this. Again, I want to divide this 2 into 2, but this 2 has to divide into both the square root of 6 and the 2. Since it doesn't divide into this square root of 6, I cannot divide it into this 2 here. All right. We have no pluses and minuses, which is nice, but we have numbers on the outside. Can we reduce this? 2 goes into 4 twice. Can I even reduce this? I can. 4 goes into 4 once, and 4 goes into 25 times. So if we simplify this, we have a 2 on the outside, square roots of 1 on the inside, over 1 on the outside, square roots of 5 on the inside. Well, what's the square root of 1? It's just 1. 2 times 1 over 1 times root 5 is really 2 divided by square root of 5. But we can't leave that square root of 5 in the denominator. We're going to multiply the top and the bottom by the square root of 5. We're going to rationalize that denominator. So 2 times square root of 5 is 2 square roots of 5 over the square root of 25. And that leaves us with 2 square roots of 5 all over 5. And our last example here, we got nothing on the outside, so we can't reduce the outside. But the inside, what divides into both those? 2 does. 2 goes into 6 3 times. 2 goes into 8 4 times. Which leaves us with the square root of 4 over 2 square roots of 3. The square root of 4 we can simplify into 2 over 2 root 3. And do you notice we now have 2's on the outside? We can cross those out. And you're left with 1 over root 3. Oh, that seems pretty simple, but again, we have that square root in the denominator. So I'm going to multiply the top and the bottom by that square root of 3. And we get 1 times square root of 3 is square root of 3. And the square root of 3 times the square root of 3 is square root of 9, which becomes the square root of 3 over 3. That's on the inside and this is on the outside, so you can't reduce those. Guess what, guys? That's it. Hopefully you've enjoyed this and you had fun, because you know what? Math is fun. Woohoo! Have a great day.